to Tech Talks by BIS Infotech. I'm Nikita Kumari, sub-editor at BIS Infotech. And in today's session, we are joined with the two founders of GalaxEye, Mr. Kishan Thakkar, co-founder and VP of Engineering, and Mr. Rakshit Bhatt, co-founder and VP of Product at GalaxEye. Thank you so much for joining this meeting and thanks for taking the time to speak with us. Okay, so before we start, I'd request both of you to introduce yourselves a bit and tell us more about the company.
Sure. Let me just get started there. So, hi, I'm Rakshit. I am the co-founder and VP of product at GalaxEye. My role is to basically use AI and cutting edge, software technologies to build products using satellite data that add value for our customer. And a bit of background. So, I'm from IIT Madras. I was also one of the key members of the Avishkar Hyperloop team back in IIT Madras. Post which I have also worked as an AI researcher at Siemens, and post which I have co-founded GalaxEye alongside Kishan and my other co-founders.
Okay, Mr. Kishan, to you.
Yeah. So I'll continue. I'm Kishan. I'm also one of the co-founders and VP of engineering here at GalaxEye. I mainly look after the satellite development and the development of different algorithms that help us do autonomous mission operations and planning and those related aspects. And I deeply work with Denil, who's the CTO. We both work on the entire technology related aspects while he focuses on the payloads and I focus on the satellite and operations. But yeah, my background, I'm from Ahmedabad, Gujarat. I did my bachelor's in material science and metallurgy. I've been excited about space since almost I was born, and have been working on many projects on the side. Even during bachelor's, I got to work on different fields: electronics, magnetism, levitation. I work even nanoparticle manufacturing. So I dwelled myself into different fields and uh, just love engineering at its core. So uh, happy to answer any other questions that are there.
Okay, so Mr. Kishan, as you said that you studied metallurgical engineering at IIT Madras, then you led the Avishkar Hyperloop team. So how did this experience shaped your engineering and problem-solving approach today?
Yes, yeah. So firstly, have being at IIT Madras itself was one of the biggest opportunities, and being around like brilliant people like the co-founders that I have here. So all of like it is a very nurturing environment, and IIT Madras brings in a place called Center of Innovation, C5 we call. So there you can they call it come with an idea, take a product sort of a thing. You can come and try out anything that you want. And so even though I got to experience the depths of material science and metallurgy, and with that I understand how uh, silicon manufacturing, how electronics at the core work. On the other hand, I also got to experience how, while building Avishkar, I got to experience how electronic engineering and electronical systems work, especially in vacuum. Very similar to how uh, satellites work, similar technology to satellite technology. So these two sort of helped me shape my skill set and m- my interest of being in space. Like all of these helped me get an understanding of how all these things work. But especially it has always been that been around very good people and had that opportunity. Special big thanks to IIT Madras for that.
Okay, and Mr. Rakshit, you have also a diverse experience from IIT Madras to Dresden and then Simon. So, how these experiences shaped your approach at space tech products at GalaxEye?
So, talking about IIT Madras, the experience at IIT Madras was more towards like trying to solve uh, the next generation of problems like working on Hyperloop and things like that. So we really did not have any exposure to the corporate world, but we were more like, raw problem solvers. We developed like the raw problem solving capability as students. When I went to Siemens, I saw how things work at scale from a corporate lens, right? How different processes are, that there is an HR department, separate HR department, separate finance department. So I think that gave me a lens, a different lens towards seeing a different approach to governance and problem solving, right? And I think at GalaxEye, we are sort of now either is extreme. Siemens was heavily corporate, whereas Avishkar was heavily raw. I think at GalaxEye we have to blend, right? We have to blend. We have to find the perfect balance between velocity and scale. So I think even though things are constantly evolving, I won't say that whatever I learned at IIT Madras or Dresden or Siemens is completely applicable here. But at least that was some exposure towards what kind of processes we should set up here so that there's not too much friction, and what kind of problem solving attitude should be. It helped us understand what kind of culture do we have to build in our company.
Okay, so you both have like incredible individual journeys, and now let's talk about what brought both of you to GalaxEye mission. So, Mr. Kishan, what was the thing, what was the gap in Earth observation that convinced you a fused SAR plus optical imaging can be a true game changer?
Yes, yeah. So, so I'll go again back a bit more into the history. So when we were together working on Avishkar, we
Mm-hmm.
got a chance to meet Elon Musk in 2019, and we were in San Francisco talking to many companies in the satellite imaging domain.
Mm-hmm.
And that's where we understood the current where the current market is and what is going on in the world in terms of satellite imagery right now. And mainly a big shout out to Suresh, who's the CEO. So after 2019, he graduated from IIT Madras, and he had gone back to TCS. He was
Mm-hmm.
working with the CEO there, and that's where he was presented with a problem statement of doing wildfire detection using satellite images for a customer in USA. That's where it clicked the switch that okay, he's not able to use optical images because of the smoke. He's not Because of the smoke, optical images are useless. And there was a different kind of imagery that we all had gotten to know when we had gone to USA, called synthetic aperture radar. Now that image was not understood well by anyone in the TCS office at that point. So this made a very uh, this was a very strange that after so much observation that there exists a very intuitive data set, but it will not be available when you need it. It will be blinded by smoke or clouds, or you'll it'll not be available at night. And there's another data set which is widely available, and it but no one understands it. People who have done PhD in understanding a radar image, it's like only a doctor who's done radiology will understand an X-ray image. Now we can try to make shapes out of it, but we can't understand it anything. So we understood this gap, and that's where Suresh called all of us together. Me, Rakshit, all of us, we got together around. It was during the COVID time. We would got together online or uh, offline if possible, and we discussed. And then it was a 1 year long journey where we validated with a lot of customers that if such a data set is present with fusion, where we can fuse both optical and SAR, would they be willing to get it? And we got a lot of customer interest. And I would let
You have also shifted from industrial AI to multi-sensor imaging product. So what inspires you for this shift?
So I think it's the nature of problem itself and the kind of impact that it can create. So first thing is that we are not building a very typical SaaS kind of a product, or we are not building any small hardware, right? It's India's biggest private satellite till to date. Only
Mm-hmm.
ISRO has built a satellite which is more massive than us, right? So when you so as technocrats or as technologists, right, I think one thing that brings us the most joy is solving these tough problems at scale. So I think one is that, and I think second thing is that, when you put up that kind of a thing in space, when you put up a satellite like we are putting up in space, right, it is very important from the perspective of national security, from the perspective of sustainability, and from the perspective of even financial growth, right? So the impact of the problem that we are solving is huge, right? So there are a lot of problems that we can unlock with our data which would not be possible without it. So as Kishan was talking about, forest fire is one thing.
Mm-hmm.
It's I think it's one of the most important assets when it comes to national security.
Mm-hmm.
Considering we have the capability to look through the clouds, we have the capability to look during night times, right? I think that's the kind of capability that you need. um, and that's just barely scratching the surface, right? In terms of sustainability, also agriculture, aquaculture, there are a lot of different problems which can be solved using our data, which even we don't know at this point, right? Because as any new technology comes, when it comes, people realize later the kind of things that can be solved using that technology, right? So we are at a juncture where we are solving a very very tough problem, and we are creating a very new kind of data set called as SyncFuse Optosar data set, and we'll put it out to the world, right? We know that there are some very impactful problems which can be solved using this data, but we'll put it out to the world and see, what other people can, how other people can use it.
Okay, so let's shift to the core technology of itself. So, Mr. Kishan, what were the toughest engineering hurdles you faced while integrating SAR and optical payloads on a single satellite bus? And because that is an extremely difficult task.
Yes, yeah. No, it's extremely difficult actually, as you put out. Many companies. So I want to put out that the one of the biggest challenge comes in building an expertise on both the payloads.
Mm-hmm.
Many companies struggle to build one payload at a good level, uh, and I think that's where me and Daniel we synchronize ourselves as well on both the payloads very well. One focus I focus on the optical, Daniel focuses on the SAR, and we have constant arguments on how to or like team level arguments on how can we do this in a much more better sense. So the biggest hurdle, as I want to put out, is understanding both the payloads to the core, and then there is a part that I cannot reveal completely, is where our IP lies on how exactly we do it. uh, but it involves uh, extremely good engineering at the satellite level, where you have to align both the payloads together. Then it requires extremely good synchronization at the electronic clock level synchronization. So that's where we tune the architecture of the payloads such that they both work in sync. And third is where an AI layer comes, where on top of the data that is captured, we
Mm-hmm.
then bring in a more refined uh, fusion layer. So these three things together enable us to actually do, and this is something that we patented around 4.5 years ago, right when the company started.
Okay, so now we have the hardware comes to the real magic basically happens with the data. And so, Mr. Rakshit, like what are the perspective from a product perspective? What unique value does Fuse SAR plus optical imaging like deliver that the traditional EO cannot?
Uh, Both traditional EO or traditionally SAR itself also has
Mm-hmm.
limitations.
Mm-hmm.
EO has the limitation of not being available when you want it to. Right? So
Mm-hmm.
right now, if you want to take an image over Bangalore, you can't because the sky is cloudy. Right. So let's just think of a very critical situation where there is something like a forest fire, or let's say there's a war going on and you want to take an image, but you can't take an image. You are helpless. SAR can fill in, but again, SAR itself has a huge issue that it's like a X-ray or an MRI. You need a doctor every time you have to interpret, right? Someone like me and you cannot interpret it, right? So that's where it's another roadblock, right? Where you get an image, but then you don't have as many people who can understand SAR, right? So that's where we are trying. That's where Drishti will come in. So the data that we will get from Drishti will basically be as intuitive as an optical image, and it will be as available as a SAR image. So anyone at any given point of time can easily interpret it, and at the same time, it's available irrespective of what kind of weather conditions are, what kind of lighting conditions are, 24 into 7. If you want an image over an area at any given point of time, we can get it for you. So that's where that's the real value, right? That's the real value that now you can have consistency in your SLAs or in your whatever is it that you want as a user. I want consistency in my value, right? I don't want that there's an unpredictability that I'm getting a result today, but I don't know when the next result is going to come out. If I need it every day, I need it every day. If I need it every week on Monday, I need it every week on Monday. So that kind of consistency and predictability we can provide to our users.
Okay, so Mr. Kishan, as Mr. Rakshit said about the Mission Drishti, so could you please elaborate on the Mission Drishti?
Yes, yeah. So very happy to. So I want to. So Mission Drishti is our first satellite mission, and that's
Mm-hmm.
launching by Q1 next year. And I
Mm-hmm.
would want to emphasize that this is when it is launched, it will be the biggest satellite launched by a private company, and we have tried to make it as small as possible for because it is not an it is very expensive to build such satellites, but the amount of technology that goes into it, it is and since there are two huge payloads on top of it, and this whole satellite comes to around 180 kgs right now. uh, I The satellite is being assembled right behind this wall right now. So
Mm-hmm.
uh, and like very happy to show it to the world in a couple of weeks and how the satellite is looking. And will soon be, as I mentioned, will be launching it by Q1 next year, and data should be commercially available by Q2 of 2026,
Okay. Okay,
end
so
of Q2.
okay, and
Yeah.
let's talk about when the satellite is in orbit. So, Mr. Kishan, could you walk us through the whole pipeline, like from raw data collection to where the data reaches the ground?
Yes, yeah. Very interesting question. Not many people ask this.
Mm-hmm.
So, since uh, since this is a one of its kind or world's first such satellite, there are some complications that go into it. But we are bringing in as much user friendliness that is possible.
Mm-hmm.
So, any if you, let's say, if you want to order a satellite image, you can come to the platform, and you will be able to, let's say you want to take an image of Bangalore, and you have some flexibility on what sort of a configuration you want to have. Or if you don't know what configuration it is, we will tell you the best configuration based on your application. uh, Now, uh, the platform will automatically tell you when will the satellite reach your location and take an image for you, and it will also automatically tell you when you will get your image back. So it is like you can say that within a week of someone ordering an image, we can deliver the image, we can deliver the image to them. And if someone plans it very well, like Rakshit said, that if I want an image on Monday every week, then such situations can also be catered very well. Then you will get an image of a particular location on Monday every week, or it can even be faster than that. You can get an image every 2 days of any location if you want.
Okay,
Now, these
so
are very specific for very, this is based on application. For example, if you want to monitor ports, then they would
mhm.
want to take images in a different frequency. If you want to monitor the border, then you would want more consistent monitoring.
Okay, so like when the data reaches to the earth, Mr. Rakshit, your role begins here. Like, how do you interpret the raw data into an analytical ready, analytical ready, useful data?
So we have our own pipelines. When we get the data
Mm-hmm.
from the satellite, it is not in a state where anyone,
Mm-hmm.
not like a regular image that we are used to seeing. So there is a lot of pre-processing pipelines that we have built on our own, which runs on the top of our data sets, and they create an image which anyone can look like and is familiar with. So that's the first part to it, and we have already tested a miniaturized version of our sensor on aerial platforms. So we have already built these pipelines, right? And the second thing is, apart from analytics ready data set, we also do a lot of AI on top of ARD to generate or transform the data set into a form which is more comfortable for our user, right? So someone might want to count the number of agriculture fields, or
Mm-hmm.
someone might be interested in basically understanding how many aquaculture ponds are present in a given region, right? So depending on what exactly are the user's requirement, we, apart from ARD, after ARD, we have another set of algorithms that run on this
Mm-hmm.
data and basically deliver value to the user.
Now let's talk about the real world impact of this satellite. So, Mr. Kishan, which real world applications have validated the fusing imaging model, and how does this differentiate GalaxEye from other players?
I would actually want Rakshit to answer this because he will be able to answer this much better.
Mr. Rakshit,
Yeah,
to you.
so as I said, right, there is not one or two points where it
Mm-hmm.
adds value. There are actually many things, right? So to
Mm-hmm.
starting with, the most basic thing was what I talked to you about, right? With our satellite, there, the first thing that we are solving for is the consistency of data. You can
Mm-hmm.
get the data when you want the data, irrespective
Mm-hmm.
of how the earth is on that particular day, right? That's first thing. Second thing is, with fusion, you can do things like, or there is a potential to do things like creating 3D maps of the earth by just fusing SAR and optical images. So that's another big thing, right? 3D maps are the new is the new coming technology. So which is proving to be useful in many things. So that's another thing. Third thing is basically AI, right? So as the new generation of AI models need more data, right? Even when you use a chat GPT, earlier you used to just type in your query. Now you give it images, you
Mm-hmm.
talk to it, and then also you give it information from many sources, and then it is able to give you a better answer, a more accurate answer, right? It's true for all the other AI models. The more information you give it, the better output it will give to you, right? So if we have two different perspectives, right, two different images of the same region, and we are giving it to our AI models, the accuracy increases many folds, right? So to begin with, these are some of the advantages, right? Predictable data, or building 3D maps of the world, or increasing the accuracy of our AI model. So these are some of the areas to start with.
Yeah.
See, but the
Okay.
And
ultimate goal, impact that this technology is going to have is, we always say that GPS, when it came in the 80s and the 90s, it was unknown to the public, right? Because it was a military tech. It started by being a
Mm-hmm.
military tech. Then 5 years later, people realized that I can use it to track my delivery,
Mm-hmm.
right? I use it for logistics. I can use it for so many things. And now we cannot imagine our life without GPS, right?
Mm-hmm.
It has been that way with the imaging technologies, right? And that has largely to do with the data inconsistency issue. You don't just imagine, if you did not get a GPS value when you wanted to, would you use it? Would
Mm-hmm.
anyone use it, right? You want to
Mm-hmm.
track your, but you're not getting the GPS value. You don't know where it is. Right?
Yes,
It's the
yes.
same problem with satellites today. You want to get an image, but you can't. You don't know whether you're going to get an image or not.
Mm.
So we want to solve that problem, and we want to see, and we basically want to make sure that this technology gets as democratized as GPS is today.
Okay. Okay, so Mr. Kishan, there must be a challenge while making this satellite of sensor alignment. So how do you how have you achieved precise alignment between SAR and optical imagery in orbit is because it is a complex task, and how do you ensure co-registration and synchronization under real conditions?
Yes, yeah. So, so one, I'll go to a term that Rakshit put out earlier, like velocity, and also
Hmm.
uh, I forgot the other term. But yeah, the point I'm trying to make is
Hmm.
we have a huge team of very young people and
Hmm.
enthusiastic people, and all the credit goes to them that they are able to do multiple iterations of the same, try to identify the best approach. And this young team is backed by a huge number of advisors from ISRO and DRDO and other prestigious institutions like IIT Madras. Uh, so what ends up happening is that the team can try out multiple different scenarios in a week and validate them with the advisors. And in this way, we have been able to improve our methodology and strategy over the past few years. And we also closely work with like ISRO facilities. We have an MOU with InSpace, and we have actively been using ISRO facilities for much of our um, testing. And similarly, we are in touch with ISRO for using their facility for alignment activities as well. So we bring in our idea and the latest state of the art instruments that ISRO has to provide, and that's how we are able to achieve much of these things. And there's a huge support from the government as well, and really thankful for that as well.
You see like automated tasking and advanced fusion shaping the GalaxEye's product?
Uh, Automated tasking, I think, has been pretty much standard now. It's nothing new that we are doing.
Mhm.
I think major thing is fusion,
Advanced
right?
fusion.
Advanced fusion, right? So I think that fusion, if you think about it, has pretty much been very standard in all of the other industries, from medical to automotive,
Mm-hmm.
right? I think as a space industry, we have been lagging when it comes to fusion, right? So I
Mm-hmm.
think right, we're just playing a catch up with the rest of the world. Uh, if you pretty much take any other industry, right, not no single sensor can do the job, right? You
Mm-hmm.
have MRI scans, X-rays to do the
Mm-hmm.
diagnostics of
Mm-hmm.
one single sensor cannot identify all the issues, right?
Yeah, yeah.
So it's just the case with space as well, right? We have long been stuck with one sensors, and again, because of that, we have not been able to democratize. We have not been able to solve. We have been only stuck with some very few problems like in agriculture and in disaster. We have not been able to expand the scope of the kind of problems we can solve using imagery data like we did in GPS, right?
Mm-hmm.
So I think it is going to enable that. It's going to make sure that everyone can use satellite data to solve
Mm-hmm.
any kind of problem that they want to solve, right? And then they will not be facing any consistency issues. They will not be facing any they will get a complete data set to work with. They won't they won't have to go anywhere else, right? So I think that's the kind of impact that is going to have.
Okay, so before we wrap up, I want to touch on the human side of the deep tech company. So, as we all know, every space tech company or startup has its difficulties during its initial phases, whether it is technology and funding or any kind of uncertainty. So, how do you, as an individual or as a team, face that, and what other things have kept you motivated till now?
I think for number one thing that keeps us, so first of all, we don't think of these things individually. We think of it
Mm-hmm.
as a team, and I think that is why. So apart from the founding team, right, we have an exceptional team of
Mm-hmm.
we have an exceptional team at the founder's office. People
Mm-hmm.
like Ritik, the chief of staff,
Mm-hmm.
many more, and we have an exceptional team of whenever we face any kind of any kind of problems, we just go and have a discussion with these people, and more often than not we identify the right solution, right? So
Mm-hmm.
that's number one. I think what keeps all of us motivated is the mission,
Mm-hmm.
right? So first thing is because we are solving a very very tough problem, something that has not been solved in generations and which is being solved for the first time, and pan Indian company, right? So I think we are trying to put India at the landscape of the global space tech ecosystem, and if when this happens, it is going to be a huge deal, right? For the first time, a groundbreaking technology proven by an Indian company, right? So it's the hunger to achieve those kind of milestones that I feel that keeps all of us very very motivated, and then of course the impact that this can create, right? From a national security perspective, from a sustainability perspective, there's a UN has identified, I think, some sustainability development goals, right? I think there is a good chunk of them that you can solve with satellite data, right? So those are the kind of things that keep us extremely motivated.
Okay, so with that, we wrap up this session. Thank you so much for taking the time to speak with us, and thanks to the Kishan Thakkar as well that he take out his precious time to speak with us. And it was lovely talking to both of you. It was really great to understand engineering perspective and AI perspective at GalaxEye. And we as a team wishes all the very best to GalaxEye for their upcoming mission and all their future missions. And we are really looking forward to seeing the milestones you achieve. Thank you so much for joining us. Have a great day ahead.
Thank you so much, Nikita. Have a great day as well.
Thank you.